using the slope to start from here and go that way is a good technique that's illustrated in this activity. And so here's the idea. Negative 1.5 over 1 we used to start from 8.6 and go this way. I should say that way. And is based on this positive 1. I mean, positive 1 along this axis means going up each time by 1. If we use a negative 1 and change this to positive, it would still have the same numerical value, so the slope wouldn't change, just using it in a different way. In other words, if we use the slope this way, 1.5 increase in v over a negative 1 decrease in t would help us go that way along this t-axis. In other words, this similar slope equivalent to this guy tells us this, that we increase the value v every time we decrease the t by 1. In other words, if we start here, decrease that by 1 will result in an increase of 1.5 there. So numerically we have this. This is what our slope is telling us, that the output, we add 1.5 every time we decrease that by 1. So this arithmetic is to be done. So that's 1 and 16.5 is another point on our slope. So I mean on our line. So 1, 16.5, and you can see that right there. And we just need to know when the 0 value for the t is and the corresponding for that. So we need to do it one more time. If we decrease this by 1 and add 1.5, this is what this slope version is telling us, then we'd have this 0, adding those two and adding those two, we get 18. Oh, it's 18. 18. So 0, 18 is that point right there. So our vertical intercept should be written this way, 0, 18. That is the location where this line crosses this axis. And again, this would mean, hopefully you can say and agree to that this is the number of years. So at 0 years, your value was $18,000. So a good sentence would be, the initial value of my truck when purchased was $18,000.